This video is all about algebraic proof. Now this guy here is making a mathematical statement. He's saying multiplying a number by 2 will always give an even number. And I'm sure reading that some of you will straight away agree with that. Some of you may be thinking of some numbers. Some of you might be thinking, well, I know 5 times 2 is 10 and I know 10 times 2 is 20. They're both even numbers, so it seems like it works. So some of you might be thinking like that as well. Here's the same guy. He is making another mathematical statement. He's saying that multiplying a number by 3 will always give an odd number. And I hope that some of you are treating this statement with more skepticism, because it may work for some numbers. If I multiply 5 by 3, I get an odd number, I get 15. But if I multiply 2 by 3, I get 6, which is not an odd number. So this doesn't work. Here the same guy is making another statement. If we multiply a number by 2, you get a multiple of 6. And he's saying that that's because if I do 2 times 3, I get 6, which is a multiple of 6. And if I do 2 times 9, I get 18, which is a multiple of 6 as well. So he's come up with 2 examples that proves his statement. But then this smart chap over here is saying, well, that's true, but what about 2 times 5? That's 10. That's not a multiple of 6. What about 2 times 7? That's 14. That's not a multiple of 6. So actually, it may be true for the 2 examples you found, but I found some examples where that doesn't work. So I found some counter examples. So this is why when we are doing when we're doing proof, we can't use specific numbers. You can never prove something is true by just talking about specific numbers, because somebody else can come along and say, well, yeah, that might be true, but what about this other number? Is it true for that? What about this other number? What about this other number? And obviously we cannot write down for every single number possible. So that's why we use algebra. And at the end of this topic, we'll be able to prove something like this, where it says the difference between consecutive square numbers is always odd. So for example, the consecutive square numbers, so the first 2 square numbers are 1 and 4. The difference between those square numbers is 3, which is odd. But is this always going to be true for any consecutive square numbers that you can think of? So like I say, we cannot use specific numbers for this. So we have to use algebra. So instead of thinking of a specific number, we're going to think of the number n, and that n can represent any number at all. And if I can prove that a statement works for n, for any number, then I know it will always be true. Before we get into some examples, let me just go through some key words and what they mean in terms of algebra. So the first one is consecutive. Hopefully you know that consecutive means one after the other. So if my number is n, the number after n would be n plus 1. And the number after that would be n plus 2. And the number after that would be n plus 3, and so on. The number before n would be n minus 1. So these are all consecutive numbers. If I'm talking about, these are consecutive as well. If I'm talking about 2n, the number after 2n would be 2n plus 1. The number after that would be 2n plus 2. The number after that would be 2n plus 3, and so on and so on and so on. So these are what we call consecutive numbers because they are one after the other. If I'm talking about even numbers, well, an even number I'd represent as being 2 times n, because it doesn't matter what this n here is. N can be any number here, could be 1, 2, 3, 4, 5, 6. It doesn't matter what n is. When I times it by 2, it's always going to be a multiple of 2. It's always going to be in the 2 times table, so it's always going to be an even number. So if I want to represent an even number with algebra, I always write 2n. if I want to represent an odd number, now I know that an odd number can be represented by 2n plus 1, because I know that this is an even number based on what I just said up here. I know if I times anything by 2, I get an even number here. And I also know that if I add 1 to an even number, I will get an odd number. I could also represent an odd number by doing 2n minus 1. This would represent an odd number as well, because I know that 2n is going to be an even number, and when I subtract 1 from an even number, I will get an odd number. I could do 2n plus 3, that would represent an odd number, and so on. So this is how I will always represent even numbers. This or this or this. These are different ways that I can represent odd numbers. Usually like this, though, this is the simplest way. If I'm talking about consecutive even numbers, so this is even numbers one after each other. The first consecutive even number, the most simple one I could do, would be 2n. The next even number after that would be 2n plus 2. Because I know the number after 2n would be 2n plus 1. That's one more than that, but that's an odd number. The next even number after 2n would be 2n plus 2. And then the next even number after that would be 2n plus 4, 2n plus 6, and so on. So these are consecutive even numbers. And then those would be consecutive odd numbers. So this is how we can represent different types of numbers using algebra. Now we're going to have a look at 3 quick examples of actual proofs doing this. So this says, prove that the sum of 2 consecutive whole numbers is always an odd number. So consecutive whole numbers, let's write those down first. What are our consecutive whole numbers? So if our first number is n, then the number after that, the consecutive one, would be n plus 1. And I want to do the sum, so I want to add these two things together. So this is me adding those two numbers together. And I know that n plus n is 2n. So this simplifies to be 2n plus 1. And given that I know that 2n is an even number, I know that 2n plus 1 will be an odd number, which is what I needed to prove. I have proved that it's going to be an odd number. So that's it. That's all I need to do for that proof. Next example, getting a little bit trickier. Prove that the sum of 2 odd numbers is an even number. So my 2 odd numbers, so there's the first odd number. It doesn't matter what n is. When I times it by 2 and add 1, I get an odd number. So this is always an odd number. Now I need a second odd number. I'm going to write the second odd number like this. 2 times m, a different number, plus 1. So this represents one odd number, where I've just times a integer n by 2 and then added 1 to it. And this represents a different odd number. So for example, if I were to pick a specific one, if n was 3, my first odd number would be 2 times 3 plus 1, so my first odd number would be 7. And then if m was 10, then this odd number here would be 2 times 10 plus 1, so 21. So I'd have 7 and 21. But we're not doing specific numbers, we are doing it with algebra. So these are both odd numbers. And I want to add them together. So when I add those 2 odd numbers together, I get this. Now I can collect up the like terms here. The 1 plus 1 is 2. And I know that I can factorise out 2 here. And I want to do that because I'm trying to prove here, that this is an even number. so is a multiple of 2 in the 2 times table. So that's why I factorise the 2 outside, to show that it has to be an even number. Right, third and final example for this video. I want to prove that the product of 2 consecutive even numbers is an even number. So let's start off consecutive even numbers. So my first even number is 2n. My second even number, the one after that, will be 2n plus 2. This is the consecutive even number after that one. Product means multiply, so I'm going to multiply those two things together. If I expand those brackets out, I get this. And I'm trying to show that this is an even number. So if I factorise 2 outside of this, this will allow me then to say, yes, this is a multiple of 2, therefore it is an even number. I could even go one step further and factorise a 4 outside and say it is a multiple of 4, as well as being a multiple of 2. But the question asks me to show it's an even number, so it's useful to write it like this. Anyway, so that's how we can represent even numbers and odd numbers and consecutive numbers, and how we can then use those to construct our algebraic proofs.